Brett Latham, back with AP Economics. Okay, we're moving on to Module 3, which is the economizing problem. We're going to talk about trade-offs, opportunity cost, and economic growth in this module. Okay, first thing we need is the production possibilities curve. This is an example of a production possibilities curve. Up here is whoa, hold on there. Let me try something here. Okay, up here is coconuts. Down here is fish. Okay, and then we can produce 30 coconuts. We can produce a total of 40 fish, or we can produce some of one and some of the other. But in order to produce coconuts, we have to give up fish. In order to produce fish, we have to give up coconuts. We can't produce 30 coconuts and 40 fish. Okay, that's opportunity cost. So you should have this drawn. Okay, coconuts up here, fish down here. Don't worry about the numbers. Just realize it shows the trade-off between coconuts and fish. Okay, you've got that. Okay, now there's some assumptions here with every production possibilities curve, and you need to make a note of these. Okay, resources are fixed. Okay, resources fixed. Okay, just a point in time. Technology is constant. In other words, you can't have improvements in technology. And the economy produces only two types of products. And that's just a simplifying assumption. And it's like, of course, that doesn't make any sense, but it does for comparison purposes. If you can understand one, you can understand multiple situations. So in economics, to simplify the model, we only have two products. Okay, now what I want you to do is I want you to draw a production possibilities curve, okay, and label it pizza. Let's put pizza up here, bulldozers down here, and then fill in these numbers. So up here would be 200 pizzas, and then down here would be 100 bulldozers, and then draw the numbers here and here. So pause the video for a second, see if you can go ahead and fill that in. Okay, we're back. So here's what you might, a representation of what you might have drawn, right? I could do 200 pizzas. I could only do 100 bulldozers. You can see it's kind of proportional here. 100's about half the size of 200. That's kind of helpful for you visually if you do it that way, okay? And then on here, I want you to add something. Anything on the curve is efficient. So put a point on the curve, label it efficient. You know, this point here, this would also be efficient. This point would be efficient. You could add points if you wanted to, but make sure on the curve is efficient. Inside the curve, well, I could produce 80 pizzas and 60 bulldozers, but I'm only producing 20 bulldozers, so I'm inefficient. And when we get into macroeconomics, we'll talk about that's kind of a recession inside the curve, but that's inefficient for now. And then out here is unattainable. Well, I want to produce 200 pizzas and 60 or 80 bulldozers. I can't do that. Not today. Maybe someday with growth I can do it, but I can't do it today. So efficient, inefficient, unattainable. Those are really important. Okay, now, opportunity cost. What is our trade-off between pizzas and bulldozers? Okay, if we look back here, well, I can have 2 pizzas for every 1 bulldozer. So the trade-off's 2 to 1. 2 pizzas for 1 bulldozer. And so as I look at opportunity cost, every time I want to make another bulldozer, I have to give up another pizza. And if you're struggling with 2 pizzas and 1 bulldozer, that doesn't make any sense. Well, think of this maybe as this is 2,000 pizzas to 1 bulldozer. So it's like, it's just a way to illustrate it. Don't worry too much about the exact numbers. Okay? So if I want 20 bulldozers, how many pizzas do I have to give up? I have to give up 40, 2 to 1. Okay, if I want 40 pizzas, I only have to give up 20 bulldozers because same thing, right? I can get 2 pizzas for 1 bulldozer. So that's how opportunity cost works. And remember, since we're only talking about 2 items, the opportunity cost of any one item has to be the other item because you can only have one or the other. Okay, here's a graph. I want you to take a look at it, and we're going to answer these questions. First question, I want good A, assume good A is producing 0 units, and now we want 1 unit of good A. What do we have to give up for good B? So pause the video, answer that question, and we'll go over it in a second. All right, so I was at 0. I want to go to 1. I look up here. I did at 0, I had 12. Now I only have 10. My opportunity cost was 2 units of good B. I could have had 12, now I can only have 10. Moving on, the opportunity cost of increasing production from good A from 1 unit to 2 units is a loss of how many units of good B? Pause the video, answer the question. Okay, we were at 1, so we had 10. We've moved to 2, come up here. We're down to 8, 2 units again. So 2 units for the first one, 2 units for the second one. Going from 2 to 3. Pause the video. Same answer, right? 2 to 3. We were at 8. We're going to now be at 6. Still 2 units. So is this increasing opportunity or constant opportunity cost? Well, the answer is constant, right? 2, 2, 2. So when we trade off good A and good B, it's a constant relationship. It doesn't increase. That's important. We're going to talk about that more as we go along. Okay, with an increasing opportunity cost per unit. Increasing opportunity. Let's talk about pizzas and robots. If you think about it, who makes pizzas, right? People that are a little artsy, right? You toss the, you spread the pizza out, you make a ball, you roll it out a little bit, you toss it up in the air. You do all that kind of crazy stuff, and you throw together a pizza. Well, how big is the 16-inch pizza? Well, it's probably about 16 inches, but if you measured it, it probably really isn't 16 inches, but it's in the ballpark. Okay, you're going to do a robot that's going to fly into space and keep people alive, some spaceship or something like that. Well, do you want that same guy that's tossing pizzas up in the air to be doing your spaceship? And the answer is probably no. You want an engineer that's going to get it dead correct, right? Or in your case, not dead. Okay, you want it to be perfect. So what happens if you have this engineer make a pizza? Well, the engineer's sitting there measuring the pizza. He's got to make it perfect. And it takes him 2 hours to do it, and each pizza is $350. And you're like, yeah, I don't think so. Or alternatively, you get in a spaceship with some guy that's like, that doesn't seem to fit exactly right. Just kind of put a little putty on there, a little duct tape, everything will be fine. Well, duct tape's really good, but I'm not sure if I want my spaceship to be designed with duct tape. Okay? So increasing opportunity cost looks like this. In other words, at first, as I give up, as I make a little bit of this, I lose very little. And then I lose a little bit more, but as I get to the end, all of a sudden I start to gain some, I lose a lot. Because it turns out engineers aren't very good at pizzas, and pizza guys trying to make a robot or a spaceship or whatever, they're not very good at that. That's increasing opportunity cost, and it looks like this. And we'll get into that more too. Okay, constant opportunity cost. What's that look like? Well, if you remember, right, it's a straight line. Okay? So it looks like that. Good old line segment, connect the y-axis and the x-axis, you're good. And we're going to have constant opportunity cost, right? 2 for 1, 1 for 1, 10 for 1, doesn't matter. But we know that no matter what we do, these people are just as good. And I think of like pizzas and calzones. If everybody knows what a pizza is, well, most of you probably know what a calzone is. You take a pizza, you fold it over, you kind of seal the edges. Now it's a calzone. Okay? So if you can make a pizza, you can make a calzone also. Okay. One more concept we're going to introduce here. Okay? Now we're talking about capital goods and consumer goods. Capital goods are things that businesses have to make stuff, equipment, factories, things like that. Consumer goods are stuff we like because they're cool and we like to use them and I'll play with them, whatever, eat them, whatever. Okay. Well, now we have a production possibilities curve, and you can see it's increasing opportunity cost because everybody can't do everything. So there's more technical jobs, there's less technical jobs, and so we have an increase in opportunity cost. Well, what could cause us to shift from X to Y? Well, if you recall earlier, we said certain things were fixed. Well, in the long run, they're not fixed. So if we could improve technology, these are the factors of growth, okay? So make sure you write that down. Factors of growth. First one is technology, so increase in technology. Okay, we could increase capital goods. We could build more factories, and with more factories, we could make more stuff. So an increase in capital goods. And the third ones we're going to cover today is an increase in resources. Okay, so an increase in resources. Like right now, we're finding more oil reserves all the time. That makes oil cheaper, allows businesses to operate and to be more efficient in doing all of that. So that's growth, right? So we were at XX, we moved up to YY. Well, that's a bigger economy where we can grow more. Under what conditions might an economy be at point Z? That'd be a recession, right? We're inefficient here. Okay, we're inefficient. So if the economy was in a recession, business wasn't good, we would be at point Z. And why might a government want to go from B to A? So here we are at B, where we make lots of consumer goods and some capital goods. Well, let's say all of a sudden you're going to war, where you're going to need more capital goods. You're going to need to build stuff, and so you make more capital goods. The Chinese economy is constantly making more capital goods. Their people don't buy a lot of consumer goods yet. So the government might want to switch an economy to making more capital goods. Okay, so that's the production possibilities curve, opportunity cost. We've got some trade-offs there. So that's the lesson for Module 3. We'll see you next time.